We first built our hatchery in 1989, and for 15 years thereafter, we successfully grew larvae, billions of larvae every year, without having to monitor the seawater. And it was around 2008 or so that the failures happened more regularly than the successes, and this whole issue came into focus for us. The shellfish we raise start their life as plankton, free-floating in the water. And in the case of oysters, when we have the corrosive seawater conditions, we don't have enough carbonate ions in the water. It makes it difficult for these baby oysters to build their shell. And a really critical period of time happens to be the first 48 hours after that egg is fertilized. So we were seeing a huge amount of mortality in the first 48 hours of life that we didn't understand at first what was causing it. And it was at that point that one of the leading NOAA scientists on ocean acidification came to us and said, you know, I think I know what might be causing the problem. And that was really our first introduction to ocean acidification.
It's just like the weather forecast that you get on your phone has a big, sophisticated numerical model behind it predicting things out a few days into the future. And Live Ocean does exactly that same thing for the ocean. The main challenge for making the results of our model available to non-scientists has to do with using these very large data files. And so you have to boil that down to something that's graphical and gets the answer that a person needs. That's something that's going to be enabled by Azure, is sort of spreading out the information in ways that I didn't foresee.
Addressing carbon pollution is not a small thing, and we have a lot at stake personally, and our industry isn't going to do it by ourselves. Now that we have these tools, we have forecasting tools and we have monitoring tools, and we're producing larvae successfully again, I feel optimistic, at least for now.